Welcome everyone. This walkthrough covers electron configuration with links to ionisation energy and periodicity. It then moves on to a relative atomic mass calculation using the percentage abundances of isotopes. Check out the flipchem.com website. There are links to quizzes related to this content in the description. Our username and password is here too so that you can log in. This is the format I'm going to use. Black text the question, red text additional information, blue text the answer. Pause the video at any time and attempt the question yourself. Let's get started. Here's the first part of the question. This question is about atomic structure. Write the full electron configuration for each of the following species, and we have a Cl- ion and an Fe2+ ion. You have to know the order of filling of electron shells, 1s2, 2s2, 2p6, etc. Fill the lowest energy subshell first and fill subshells singly until they have to be spin paired. Chromium and copper are exceptions to this rule. Chromium ends in 4s1 3d5 and copper ends in 4s1 3d10, where the 3d subshell can be filled evenly. Use the periodic table to find the total number of electrons in each atom. This is known as the proton number or the atomic number. For the chloride ion, we need to add an extra electron. It has a charge of -1. For the Fe2+ ion, remove 2 electrons because it has a charge of +2. The Cl- ion has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6. The Fe2+ ion has an electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. The 4 s electrons are always lost first when forming ions. Here's the next part of the question. Write an equation including state symbols to represent the process that occurs when the third ionisation energy of manganese is measured. You have to know the ionisation energy definitions and be able to apply them to balanced equations. Third ionisation energy is the energy required to remove 1 mole of electrons from 1 mole of 2+ ions to create 1 mole of 3+ ions in the gaseous state. The equation must start with 1 mole of 2+ ions and show the formation of 1 mole of 3+ ions. 1 mole of electrons are lost. State symbols are essential. Here's the next part of the question. State which of the elements magnesium and aluminium has the lower first ionisation energy. Explain your answer. Pay close attention to detail. Did you notice that the previous part of the question was about manganese and this is about magnesium? This caught a number of students out. There are 3 main factors that influence the ionisation energy of an atom. Shielding, the number of full inner electron shells. Nuclear charge, how many protons are in the nucleus, and distance, how far the outermost electron is from the nucleus. These 3 factors impact the overall attraction between the outermost electron and the nucleus. The greater the nuclear attraction, the greater the ionisation energy. There are 2 other considerations that you have to be aware of: the type of orbital that the electron is removed from and spin pair repulsion. If the main factors do not explain the difference in ionisation energy between 2 atoms, we have to consider these other factors. You should be aware of the trends in ionisation energy across a period and down a group. Ionisation energy always decreases down a group. Ionisation energy generally increases across a period. You need to be familiar with the exceptions to the general trends across period 2 and period 3 as part of your course. Periodicity is the term used to describe repeating patterns in physical and chemical properties across a period. I've given the electron configuration of both of these elements in box notation here. Both magnesium and aluminium are in period 3. They both have the same shielding. Aluminium has a greater nuclear charge and aluminium has a smaller atomic radius. From this information, you might expect magnesium to have a lower first ionisation energy. However, if we take a closer look at the electron configuration, the outermost electron of aluminium is in a different type of orbital. Let's address the question. Aluminium has the lower first ionisation energy. The outermost electron of aluminium is in a 3p subshell. This is higher in energy than the outermost free s electron in magnesium and is easier to remove. Here's the final part of the question. A sample of nickel was analysed in a time of flight TOF mass spectrometer. The sample was ionised by electron impact ionisation. The spectrum produced showed 3 peaks with abundances as set out in the table. Give the symbol, including mass number, of the ion that would reach the detector first in the sample. Calculate the relative atomic mass of the nickel in the sample. Give your answer to 1 decimal place. In a TOF mass spectrometer, all ions travel the same distance and have the same energy. The lightest ion will travel the fastest and reach the detector first. Don't forget to include the mass and the charge of the ion. Relative atomic mass is the average mass of an atom compared to 1/12 the mass of an atom of carbon-12. Multiplying the percentage of each isotope by its mass gives the mass of 100 atoms. Dividing by 100 gives the average mass of 1 atom. Take care with decimal places. It is essential that you give your final answer to 1 decimal place to get full marks. Thanks for watching. I hope you found the video useful. Don't forget to check out the website and related quizzes. Links are in the description. Comments, questions and suggestions are always welcome. Please subscribe and click the bell for notifications. Take care and goodbye.